Okay, so we're going to proceed in the second short video with number 6 and 7. So number 6 is put a matrix into Smith normal form. So put 1, 3, 0, 3 into Smith normal. Okay, so how do we do that? Well, what are we allowed to do? So remember, the Smith normal form is some matrix where there's supposed to be only numbers along the diagonal and then zeros everywhere else. So in this case, the matrix is 2 by 2, and we can tell that it is it's not invertible over Z, but it's invertible over Q, right? Its determinant is 3. So it's invertible over a field, but not over Z. Okay, so the point is that you should be able to use right row and use row and column operations to take this matrix into something that has a particularly simple form. But in fact, this problem is almost a red herring. It's kind of obvious how to do that because I can do the following row operation. So I can take 1, 3, 0, 3, and then I can do the following row operation. I can take R1 minus R2. Right? And that takes you to 1, 0, let's check it, 0, 3, and this is in Smith. So it looked like a hard problem, but it was actually trivial. It's actually trivial, right? So this is a simple row operation, so it's just a left multiplication by a single invertible matrix takes you into this nice diagonal form. So note that this is not invertible over the integers because there's this 3, but nonetheless it divides the 3 divide 1. 3 divides 1. Excuse me, 1 divides 3. Right? The thing in the top left divides into that one. Okay, so I could have asked you to do something much harder, but I'm taking it easy on you guys here. Okay, and finally, so there's 2 more problems after this, but their solutions are in the solutions to homework 5, which I'm posting concurrently to these videos. So this is the last one I'm actually going to solve out in the video series, so we're basically done here. So let P not equal Q be primes. Then the question is, how many abelian groups of order p squared q squared are there? So how many, and actually this is a little vague, I should say up to isomorphism, but of course it's kind of understood by how we've been doing the class, abelian groups of order p squared q squared. Okay, so the thing to notice is that since p squared and q squared are distinct primes, any abelian group of order p squared q squared is a product. So the first point is that A is, let's call it AP cross AQ, where this has order p squared and this has order q squared, right? So you can see this from the classification of finitely generated abelian groups. That's my Piazza answer was something like this to a question about this homework problem. But actually, I realized a minute later that there's a simpler way to see it, which is that AP is the p squared torsion, and AQ is the q squared torsion. So AP, you can actually just canonically figure out what these are. AP is little a and a, such that p squared times a is 0. AQ is a and a, such that q squared times a is 0. Right? The point is that any element of A is annihilated by p squared times q squared, because that's the total order of A. And so if you think about which ones are annihilated by p squared, which ones are annihilated by q squared, because p and q are relatively prime, that splits the thing up into a product of 2 smaller groups. So then we just have to figure out, well, how many groups are there of order p squared or order q squared? Well, they're both prime, so we just have to do one of them. So order p squared, well, there's only 2 possibilities. You have zp cross zp, and you have zp squared. That's it by the classification, right? There's only 2 ways to break this thing down. So there's 2 total. And then same for q squared. So the total answer is there's 2 possibilities for AQ and 2 possibilities for AQ. I can pick either one, and so I get 4. So to answer this problem is 2 times 2 is 4. Right? I pick one of the 2 for AP and one of the 2 for AQ, and that gives me my 4 total possibilities. Okay, and finally 8 and 9, I'll just say C compass, because those are solutions to homework 5. which I have teched up and I will be posting, as I said momentarily, concurrently with this. Okay, so the second video was really short. So that's it. So that solves all the problems except for that one about decomposing 8 and 12 or something. I mean, you know, you can ask me about that on Piazza if you want, but I figured it would be kind of a not a great use of time to upload that. Okay, so these will go up on YouTube. So like I said, either tonight or tomorrow, I'll photocopy these and post them, and the homework solutions are going up tonight as well. So that's a lot of materials. So please feel free to ask me about them as we approach the exam. All right, thanks very much.